This is Mark Pawlikowski, and welcome to the TechMates podcast, where my partner Henrik and I explore how Kiwi and Aussie founders are reshaping the future and what sets them apart. Henrik and I have been part of successful companies in Silicon Valley and Europe, and now bring that expertise to partner with entrepreneurs in Australasia. By sharing the personal stories of successful Kiwi and Aussie founders and how they got here, we hope to inspire you to dream big. This is TechMates, bringing an outsider's perspective to the stories of those daring to disrupt down under. Let's dive in.
I thought I really want to concentrate on space. And so I spent 5 years reading books and educating myself in various libraries while working in that company towards citizenship. I spent that time educating myself on the state of the art in the space industry and the problems, on what the future of it is. And the moment I got my visa, I went back to University of Auckland immediately. I went back and I studied to the Faculty of Engineering Science, which is like the superset of biomedical engineering. And immediately went into the Auckland program for space systems, which was the undergraduate program. And my thinking was that at the time I realized that rocketry is a solved problem. Not only it's solved from the engineering standpoint, because we've had rockets for decades by then, but it was also solved from the commercial standpoint. I could see SpaceX, they had their rocket. I was like, yeah, that's fine. We have access to space sorted out. Sure, there's a lot of room for optimization and perfection, whatnot. And then over the next decades, a number of players will emerge and they compete, and whoever will win. But it doesn't change really anything, materially speaking, for the industry. I thought the next frontier is in-space operations. Like, what is the next thing for in-space? How is the industry going to progress? And I've realized that we were fundamentally looking at three large bottlenecks under the umbrella of, so when we go to space, I've realized that when we go to space, we're fundamentally still very dependent on the resources of Earth. We're sort of tethered to Earth, like by an umbilical cord in a way, because every time we go to space, our satellites, they need to be agile in space. If they're not agile, if they don't have control over them, then they can't be useful in space. But our satellites rely on fuel that we bring with us from Earth. I thought, hey, you can't really build anything sustainable. You sure can get away. You can build some businesses in the very short term, but ultimately you have to go away from this to build sustainable businesses and sustainable industry. That was number one problem. If you run out of fuel in space, you're screwed. The second problem I've realized is that, hey, every time we go to space, we get absolutely fried by radiation. Like radiation here on Earth, we're protected by the magnetic field of Earth, but in space, electronics gets absolutely obliterated by radiation, and people, well, even worse than electronics. You can't have sustained presence in space without radiation protection. And the third problem that I saw was that we did at the time and still do, most of the stuff on Earth, like we could construct everything on Earth in one piece and then we'll launch it in the rocket. And whatever fits in the rocket, that's how much we can launch. And if it doesn't fit, well, it doesn't go up. You know what I mean? The only exception is like International Space Station, but that's sort of bespoke one-off project. We don't have a convenient, easy-to-use interface for sophisticated in-space operations like assembly, servicing, maintenance, whatnot. We're very primitive. So I thought these are the three pillars that are presenting big problems. And I really wanted to build enabling technology for the space industry to thrive for the next, few centuries. Sort of like, I wanted to build primitive technologies, but not in the way that they're stupid, in the way that they're very robust, very reliable, and they're like a wheel, you know what I mean? Like a wheel is a primitive.
Yeah, like fundamental building blocks.
Yeah, but wheel is so simple to replicate and it's so widely spread, So I wanted to build technologies like this for the industry, for the in-space industry, for satellites. And I thought, okay, there's one thing that is missing currently. It's an ability to generate a force reliably in space from the resource of space. And that's how we ended up working with magnetic fields, in particular with large and dense magnetic fields that are generated and sustained very efficiently and effectively. If you generate a magnetic field in space...
When you say force in space, what do you mean by that?
To do something with... in our three-dimensional sort of mechanical world, you got to affect it, right? If you have no effect, you really can't change the state of the universe. And so you need, I was looking for an effector in a way, and I sort of looked at the range of forces that are available to us in this universe, and there are some of them only present on very small scales. And the other ones we were already exploring in the space industry, but mostly they were finite, like they were relying on like finite resources. And I thought, hold on a second, if we could enable the magnetic interaction forces in space, that would be an absolute breakthrough. Because then if we had a magnetic force in space, we could fuel that force by the energy that is coming directly from the sun, and we can then use that force to solve many problems. Like when it comes to satellite fuel limitation, you could, propel satellites with only magnetic forces, and you can, point satellites with only magnetic forces. You can also protect the interior of satellites with the magnetic fields, which is a very natural way of doing this. This is how Earth itself protects us from the radiation damage, you know? You can use magnetic forces to enable interactions between satellites as well. Like when they come close to each other, you can interact like two magnets do when they come close together. And if you can control, you know, the shape of that field and the intensity of it, then you can very precisely control the nature of that interaction. I thought, hey, this is a huge potential here in enabling, you know, a force generator like this, like a magnetic engine, essentially.
Thank you for tuning in to TechMates. If you enjoyed this episode, be sure to subscribe, leave a review, and share it with friends. We'll be back soon with more stories of Kiwi and Aussie founders reshaping the future and disrupting down under. Until next time, keep dreaming big and daring to disrupt.